Let's evaluate this integral. I think this one is one of those integrals that looks really complicated, but it actually ends up being really simple. Now, the way I would approach this is by first looking at the arcsine term, because it looks the most problematic, at least to me. So, what I do know about arcsine that is relatively easy is its derivative, and that serves as my first hint. The derivative of just any arcsine x is 1 over the square root of 1 minus x squared. Now, you could just know this, or you could compute it using implicit differentiation, which shouldn't take time. And so my derivative of my arcsine x over 2 is the same thing. I just replace x over 2 instead of x. So I end up with 1 over the square root of 1 minus x over 2 squared times a factor of 1/2 that comes from the chain rule. Now, if it's not immediately obvious, this is exactly what I have contained in my denominator, it's just written differently. So if I just applied some algebraic manipulation, I get that this is equivalent to 4 minus x squared. Now, if I have a function in an integral contained with its derivative, the integration method that I should use is u substitution. So that's what I'm going to apply here, where u is arcsine x over 2, and du is exactly what I just computed, 1 over the square root of 4 minus x squared dx. And so taking out that constant 2 that I have in the integral outside and applying my substitution, my integral reduces to just u du, which is really easy to integrate. So then this just becomes the factor of 2 times u squared over 2 plus a constant c, because this is an indefinite integral. My factors of 2 cancel, and so substituting my term back in, I get that the integral is equal to arcsine squared x over 2 plus c. And that's it.